Cyclopentanol can be reacted to form cyclopentene. Cyclopentene is a liquid with a boiling point of 44 degrees Celsius and a density of 0.74 grams per centimetre cubed. A student plans to prepare 4.00 grams of cyclopentene by reacting cyclopentanol with a boiling point of 140 degrees Celsius with an acid catalyst. The expected percentage yield of cyclopentene is 64.0%. The method used is that the student carries out the preparation using the apparatus set up for distillation as shown below. 1. The reaction mixture is gently heated and a distillate containing impure cyclopentene is collected. 2. The distillate has an aqueous layer and an organic layer. The student purifies the cyclopentene from the distillate. Part A. Calculate the mass of cyclopentanol that the student should use and explain how pure cyclopentene could be obtained from the distillate. So firstly, answering the first part of the question, which is calculating the mass of cyclopentanol. So in order to do this, we need an equation triangle, and the equation triangle we're going to use is mass divided by moles times RFM, or that mass is equal to moles times relative formula mass. So the first thing we're going to do is do 4 divided by 68. So what this is it's the 4 grams of cyclopentene, and then it's the relative formula mass of cyclopentene. So if we calculate it, that's 1, 2, 3, 4, 5 carbons, so C5, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, so that's equal to 12 times 5 plus 8, which equals 68. So these are going to be the moles of cyclopentene, and it equals 0.0588 moles of cyclopentene. So we can write that next to it just so that we don't lose track later on in the question. The next key piece of information we're going to use to work out the mass of cyclopentanol is the expected percentage yield of cyclopentene. So what we're going to do is 0.0588 multiplied by 100 divided by 64, which equals 0.0919 moles. And this will be of cyclopentanol. So you might have thought that the fraction should go the other way round, but actually that's going to give you a smaller moles. And because the percentage yield is less than 100, that means you're going to need more cyclopentanol in order to make 64% cyclopentene, because some of this percentage is going to be water. Then we need to work out the mass of cyclopentanol. So again, using the equation triangle, we do moles, so 0.0919, and then multiply by its relative formula mass, which is going to be 86. So again, we can work this out. We've got 1, 2, 3, 4, 5 carbons, so C5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, and we have an oxygen. So that's going to be 12 times 5 plus 10 plus 16, which equals 86. And working out the mass, that's going to be 7.90 grams. So it's really important that you've got the mass written to 2 decimal places as well in this question. Then looking at the purification techniques. Firstly, you need to add a neutralizing agent, such as Na2CO3 or sodium carbonate. Then we need to talk about the different layers in the separating funnel. So the organic layer is going to be on the top, and the organic layer is going to contain the cyclopentene. And that's because it's going to be less dense than the concentrated phosphoric acid. Then we need to dry with an anhydrous salt, to dry the organic layer with an anhydrous salt. So that's magnesium sulfate, sodium sulfate, or calcium chloride. Finally, we need to redistill at approximately 44 degrees Celsius. And this is because that's the boiling point of cyclopentene, which we're told in the question. Part B. The organic layer in the distillate was analysed by IR spectroscopy. The IR spectrum is shown below. Explain how the IR spectrum of the organic layer suggests that cyclopentene has been formed and that the reaction is incomplete. So the key part of this question is that the reaction is incomplete and that we're trying to form cyclopentene. So if it's incomplete, that means we're going to have some cyclopentanol left. And we can see on the IR spectrum, we've got this smooth curve peak, which is our OH peak. So this is probably the easiest peak to identify because it is this smooth curve and all the other peaks are going to be jaggedy. So then we need to write our first statement. So the OH, or the alcohol peak, so naming the functional group is sometimes a good idea, just so that it's easier to check back you've definitely answered the question. And then we need to state what region it's in. So we've identified it with the arrow, but just to confirm, we need to say what wave number region. So that's going to be 3,200 to 3,600 centimeters to the -1. Then, because we're trying to form cyclopentene and it's incomplete, but we are going to form some, even though the reaction is incomplete. And looking at the datasheet, you can see the rough region of the OH peak and the alkene peak. The alkene peak is slightly harder to identify because it isn't just a smooth curve. You do need to look at the wave number region in your data book as well. But it's going to be this peak here. This is going to be your alkene or your carbon double bonded carbon peak. So if we start to write our second statement, we have our C double bond C, or our alkene peak. And the region that it's in is going to be the region of 1,620 and 1,680 centimeters to the -1. To get the 2 marks for this question, you get a mark for your statement about the alcohol peak, and then you get a mark for your statement about the alkene peak.